Welcome to lesson 3 of chapter 15. Last lesson we talked about residential uses of water. Now we're going to talk about agricultural, industrial, and other forms of water use. So learning goal or learning objective here is that you'll be able to describe the non-residential uses of water and the related concern. Success criteria is the same as last time because we're continuing with uses of water. So for agricultural use of water, in North America, groundwater accounts for about 43% of water used in agriculture, and surface water accounts for about 57%. So we are pulling water out of our groundwater resources, out of those aquifers, to water our crops. Food is important, but we're biting into our groundwater supply, which is not great. Irrigation is the major consumptive use of water in most parts of the world, meaning like irrigation would be using water to water our crops. And it accounts for about 80% of all water is consumed in North America. So there are 4 common irrigation methods. So there's surface or flood, and this requires extensive canal systems. We're literally flooding the plain. There's spray. You'll see these a lot around Oklahoma, especially on the sod farms. This requires the use of pumps. There's also trickle, so this is good if you're if you have your crops very neatly in like rows. It's strategically placed openings that deliver water directly to the roots of plants. And then there's sub-irrigation, which can be good, but takes a lot of like planning ahead and money here, obviously. So underground pipes supply water to plants and be used for drainage as well. So costs for irrigation water have traditionally been low since many dams and canals were built with federal assistance, meaning the government made it cheaper. Competition for scarce water resources is prompting communities to raise water rates for irrigation, prompting farmers to conserve. Water is getting more expensive. Farmers don't want to pay that much, which makes sense, so they're trying to figure out ways to use less. Demand for irrigation water can also be reduced by reducing the quantity of water demanding crops grown in dry areas. Arizona is a naturally dry area. It doesn't make sense to grow food there that requires a lot of water. So just making those choices of growing crops that actually work in the environment instead of artificially bringing in so much water can help us save a lot. All right, moving on from agricultural to industrial. Industrial water use accounts for nearly 50% of all water withdrawals in the U.S., 75% in Canada, and 23% worldwide. 90% of the water used by industry is for cooling and is returned to the source. So industry, we're using combustion, like in energy production. We need to cool those parts down. We use water. So very little is actually consumed because it's just used to cool and then it's returned. Most processes involve that heat exchange, so the hot surface takes in the cool, or the hot surface releases that energy of heat into the water, and the water takes it away. Water is also used to dissipate and transport waste, resulting in stream and lake degradation. So this transporting waste we talk about a lot with residential use, but it's also true for industrial use as well. So the Clean Water Act of 1972 seeks to protect U.S. waters from pollution, and it specifically regulates pollutant discharges into navigable waters by implementing 2 key concepts. 1, there's water quality standards for surface water, meaning like the lakes, the streams, the rivers have to meet these certain standards. We can't pollute them beyond that point. And then limiting effluent discharges into water, meaning we cannot just dump waste into that water, which used to be a lot more common. All right, and the last one we're going to talk about is in-stream water use, which we may not think of, but definitely counts. And that's using water and its channels, making use of water in its channels and basins. So if we're swimming, if we're boating, it's typically non-consumptive. You're not taking that water somewhere, you're just using the water in its place. So major in-stream uses are hydroelectric power going through dams, recreation, and navigation. And presently, hydroelectric power plants produce 6% of all electricity in the U.S. We talked about the pros and cons of that last semester. So although hydroelectric dams control flooding and create electricity, they do have drawbacks. They are very expensive to build. They destroy the habitats above and below the dams because that's not natural, how we're affecting them. Dams also reduce the scoring effects of flooding. And they slow stream flow and silt deposition, meaning behind that dam we have a lot of silt building up that eventually will be too much. And then the impounded water up here has an elevated evaporation rate because it's not perfectly still, but it's standing more still than it would if it was flowing as it naturally would, which increases evaporation rate, which just means we're losing some of it. So most large urban areas rely on water to transport resources. So this down here is nearby. This is the port of Catoosa. We're the most inland port in the U.S., but we are using the port of Catoosa, the river there, to transport goods. So in recent years, the inland waterway system in the U.S. has carried about 10% of goods such as grain, coal, ore, and oil. And improvement expenditures total in the billions of dollars. It is not cheap. All right. If you have any questions, please let me know, and I will see you in the next one.